Welcome to VW MOOC 24 and our second week. We have two sessions today. Our first one is coming to us from Japan, and that's with Yan Uriai or Nishimura Hajime. He's a retired JAMSTEC. He retired in 2020. He's a board member of the NPO, Japan Underwater Robotics Curator of Abyss Observatory and Second Life, GeoGrid, and Roblox, Gateway to Thinking at VWEC, Eduverse, Welcome Plaza, the Modern Museum and Climate Change Learning Portal, and creator of International Space Flight Museum and Second Life. He engaged in deep water submersible development from 1984 to 1986, global climate change research from 1986 until now, International Space Station development from 1988 to 1990, research ship Mirai reconstruction from nuclear merchant ship from 1995 to 1997, ultra deep science drill ship Chikuyu development from 1997 to 99 and from 2003 to 2005, Virtual Science Museum from 2009 until now, environment data utilization for social problems from 2010, and it's still going on, and remote classroom at Japanese Museum, SciPi, from 2017, and it's ongoing. You can find more details about him, and the link will be available in the YouTube video. And he also has a YouTube playlist. So it gives us great pleasure in having you with us, Yan. And thank you, Val Hill, who's also going to be speaking at today's session. So welcome, everyone. Sit back and enjoy.
And if you get lost in Second Life, you can ask me for a teleport. We're going to follow Yan, and I will try to help with translation as Yan is in Japan, and he has sent me some local text. So this will be a very global, interactive session and tour. We go on tours every month, right here at the Gateway to Thinking, usually on the second Friday of the month, 7 a.m. Second Life time. Today's tour is going to be about climate change, as Nellie introduced Yan. So it's time to get started, and Yan is going to tell us all about the tour. Yan?
Thank you. So I start from now. So the former US president says that global warming is a fake. And he also a leading candidate in this presidential election. And he will withdraw again from the Paris Agreement if he is elected again. Why? And he thinks it is a fake, even though it's difficult to find a country that has not ratified and signed the Paris Agreement. It is known that some organizational activities are trying to make global warming is still controversial. Unfortunately, I have to say that the conspiracy has succeeded in delaying global warming countermeasures. In the past, I thought global warming was difficult because it is a long-term scale and global scale phenomenon for each person. But nowadays, I think it is not difficult for everyone to understand something unusual is progressing. However, it is still difficult to understand on their own and whether this is due to human-derived CO2. The IPCC reports are so huge and complicated, and they are written with a lot of academic knowledge. So government and media cannot report without any omission of important explanations. What is the difference between blindly accepting IPCC reports and blindly accepting dictators' announcements? And to think about this, let's teleport to Abyss Observatory. Please come on. Please follow me. And touch the board in front of me and open your nearby chat. So there is, I need to open. There's many destinations. A1, A1, 2, 1B, C, D. So there's four category. And B, second paragraph, past, present, and futures. And number B1, sorry. Number B4, only one Earth. Please teleport and see you there. Or I'll type in nearby chat. Okay. Here is Sky exhibit at Abyss Observatory. And camera zoom out. So big starry night sphere. There is exhibit from past to future. And common please see this graph. So recent temperature rise and solar activity. For 50 years from here, 2001, and to 2015, so 15 years, it is said hiatus. The temperature increases are stagnated for 15 years. The global change deniers appeared that this is a precursor to shifting in the glacial period. But in fact, it rose sparingly. And looking at the whole hiatus itself is not so stagnated. The denial, I'm sorry. Okay. Remember this year, 2015. please remember this year. So stagnation is finished and rise rapidly. I use later. And relationship with solar activity. Please look at before 1970. Here, solar activity is increasing and decreasing a little. And the temperature rise and stagnate. So so it could be said that the temperature fluctuation correspond to solar activity. However, since then, solar activity is decreasing, but temperature continue to rise. And please look up and zoom. This is Munich Reinsurance Company's statistics of world natural disaster number. This may be affected by expanding human activity areas. And please look at red. Red is earthquake, tsunami, and volcanic activity. So these are not affected by climate change. You can see a slightly increasing, but a little. On the other hand, green, blue, and yellow is storm, flood, landslide, and drought, and forest fire. These are climate-related disasters, and they are considerably increasing. And look next graph. This is past 400 years. Past 400 years at the comparison with recent big deviation. So very stable temperature and big deviation. The variable of solar activity, variable effect of solar activity are too small, too slight to be discernible. And move to next. Past 800,000 years, changes in CO2 level during the glacial interglacial cycle or Milankovitch cycle over the past 800,000 years. In this era, CO2 and temperature are proportionally changed. CO2 decreases in the glacial period. So yellow part, decrease blue part, the CO2 decreases in the glacial period, and yellow part CO2 increase and the integrational period. Based on this graph, greenhouse deniers have appeared before that current CO2 increasing is not due to the human activity, but only due to reflection of temperature increasing. If it is in line with the appeal, you can imagine that the current CO2 level here, or so black line is 420 ppm. Is already far beyond the CO2 level in the interglacial period. And it will no longer turn into glacial period again. And next graph. This is the temperature, and above this graph there is CO2 level since Cambrian explosion 500 million years ago. And comparing these with recent temperature projection and CO2 projection. So we can see that the worst case of future projection are comparable to the past history of repeated evolution and extinction of life. And time travel is ended. Please follow me. Here is present Earth and neighbor Venus and Mars. This flower shows the present Earth and neighboring planets. I'll talk in various spatial scales from the solar system to the molecular scale. So I changed the crop. Okay. This is our Earth by visible light sensors. So cloud is shine white, but land, green, or desert and ocean can be seen clearly. Compared with Venus, this is also invisible light sensors image by Akatsuki probe. And so Venus is covered by clouds and shining dazzlingly. The Earth, land, and ocean can be seen clearly through clouds. This means that visible light is not absorbed so much in the atmosphere. That is, visible light does not directly warm the atmosphere. Then let's think about how the Earth is warmed. So please see this panel. And please imagine that you are standing with a parasol in the hot summer afternoon. The solar radiation from solar radiation may be solar radiation can be shielded by the parasol, but you can still feel hot from the ground. As shown in graph, so some part is reflect sunshine reflect by the ground a little, and heated ground heat air above ground, but more strongly more stronger is invisible infrared rays from the ground, and it's greater than and the energy coming from sun. 340 kilowatt hour per square meter, but radiation from ground is 398. This is due to the nature of object with temperature radiate light or electromagnetic waves according to their temperature. So it is a Planck's law. The high temperature sun radiation sun radiate mainly visible light and ultraviolet and infrared. And the low temperature Earth emitted invisible infrared rays like this. And so let's see the infrared Earth infrared sensor. So red color is go to north and south, and also in summer and winter. So look down from North Pole. Then in summer, but Greenland is still blue, means ice sheet on the Greenland reflect sunshine. So main green. But most of Arctic region is yellow and red because sun is not sink in summer. So so midnight sun, the night sun. And in winter, now in winter, so all is blue because sun is not rise all day in winter. So polar night. And but here is yellow region, of course, of Norway is Gulf Stream carry warm water to the Arctic. So, of course, so coast of Norway is warm, even polar night. And like this, Earth emitted infrared rays to the sky, and greenhouse gases is absorbed and start to vibrate. So please see a red arrow in panels in front of me. So this is CO2 molecule, and there's a two mode, symmetry vibration and asymmetry vibration. Asymmetry vibration emitted infrared rays around. Then we'll see it so like this, and warms ground. This is greenhouse effect. And half of greenhouse effect is made by water vapor, and 1/4 is cloud, and 20% is carbon dioxide. So infrared rays released from this Earth are absorbed by greenhouse gases such as water and CO2. Then the molecules begin to vibrate in this way. Then the infrared radiation is re-emitted to the ground surface. Then the water vapor increase is due to the evaporation from the sea, which increases the greenhouse effect. So this is called water vapor feedback. So CO2 is trigger, but so enlarge CO2 greenhouse effect by water. So how I'll talk later why CO2 is treated as a leading actor of global warming, but now let's see CO2 behavior. So back to the animated Earth, search here and select CO2. This is NASA Goddard Space Flight Museum site research center's simulation model, Earth model. February, May, March, and April. Red and is high density, and purple is more dense. But May, and suddenly CO2 is decreased. You can see the ground through the air. But see Europe, CO2 is still continue to emitting. August, most of CO2 is disappeared. September, and suddenly increasing start again. November. and December. So in summer, CO2 level is become very low. Why? We start the simulation again in February, May. And the southern hemisphere is continue to green, so ocean is absorb CO2. And there is few industrial city, industrial country. And June, so again, CO2 is decreased, disappeared from northern hemisphere. It's August, September, and October. And so CO2 is increasing again. So to think why CO2 disappeared from northern hemisphere, I'll change it to next Earth. Biosphere. So she ground green on land is vegetation, and winter, and summer. Green is spread until Arctic coast. And sea, ocean, there is a phytoplankton. So go to north and south. And each summer, there is a orange yellow is blooming in summer. Phytoplankton is blooming. And she panels beside of us and look red arrow. This photo is chloroplast in plant leaves and phytoplankton. Chloroplast contains high density chlorophyll. Chlorophyll emits fluorescence, which can be observed by satellite. The chlorophyll also captures CO2 from the atmosphere using energy obtained from sunlight. So it is photosynthesis. Then look at the Earth from North Pole. In winter, so most of northern hemisphere become white, and in summer, so green and red in sea is filled. Summer. So because in summer, you saw sunshine is always continue, so sun is not thinking. So photosynthesis is active and absorb CO2 very much. So this is because the longer hours of sunlight in the summer allow photosynthesis to be more active, causing plant to grow and spread, absorbing more CO2. This simulation shows plants can absorb most of the CO2 released by humans, but CO2 released by human exceeds the amount of plants absorbed. So Earth is gradually warming up. Then next, please touch this board and select chaos and supercomputing. 3,500 meters, or I type nearby chat. Or I'm sorry, I took one thing. So Venus is reflect sunshine in 70%. So Venus is if there is a global warming effect, so Venus become very cold planet, but by the dense CO2, Venus is hotter than Mercury for 400 degrees Celsius. And the other hand, so Mars is a very little planet, and so there is a very thin atmosphere. So greenhouse effect is neglected now. But in the past, so please my sharing screen. So there's a very big volcano activity, and lava release a lot of CO2 and water vapor. So then please see here. You can see water flow remains, or here there's water remains. So in the very old days, there is a big water flow, and there is a ocean and covered by ice. So greenhouse effect affect our planet evolution. Then we move to future Earth. So I type in nearby chat. Oh, hello, oh, Terry. So come on, please. Lawrence devised a chaotic water wheel that replaces a mathematical model of atmospheric fluctuation. the equation is like this in my sharing screen. It's with a mechanical model. So push. So glass balls are falling above and start rotating. I'll count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 5, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So glass ball holding at a constant speed from directly above asymmetry of the field and asymmetrical motion began. It is similar to vibration, but not a constant vibration. Nor is it completely random. While it is called chaos, it is generally within a certain range of oscillation. So if someone were to draw the graph with this rotational angular velocity and position of its center of gravity of water field, a figure like a butterfly spreading its wings will be drawn. Like this. And it is often said that Lorentz discovered the unpredictability of weather, but rather he taught us that by repeating calculations with slightly different initial values and processing them statically, a calculation will converge to one value or transmission between multiple values. An example of transition between two values is come here, Milankovitch cycle or integration cycle. There is a two state and a shift, and almost periodically. And another example is 9 months forecast of El Niño La Niña event. So please see my sharing screen. An example of transition between two values is the Milankovitch cycle. Another example is the El Niño La Niña event. Repeating calculation with the slightly different initial value is called an ensemble calculation. It is used for daily weather forecast in 2 weeks forecast and typhoon forecast for 5 days. Here is an example of a long-term forecast. This is a 9-month forecast of El Nino La Nina, compiled by IRI, International Research Institute of Climate and Society. Here, and there is a 17 dynamics model and 9 static model are participating. This indicates whether it becomes El Nino or La Nina above horizon axis is El Nino model, and below of axis is La Nina. It is a La Nina. So each line of models are ordinary ensemble calculations that repeated many times with one model. And X is actual observation data added later. So no one knows the reason, but there is another observation data in middle of branch of many lines, bunch of many lines. Average of these predictive models is called multi-model ensemble. Average and observation are very good. So next month, also observation data is middle of bunch, middle lines. And also middle of lines, the average. So no one knows the reason, but so multi-model ensemble is very strong for prediction. But when 2015, yes, I said please remember the age. So observation data is out of lines. The next out. So very deviate from average. So very big El Nino, super El Nino occurred. El Nino. El Nino. And back to average. So now observation data shown in average. Also average. So so multi-model ensemble is very strong, but sometimes the prediction is wrong. So that deviation is started around November 2000, September 2016. So it started to deviate around November 2013. In the end, the multi-model ensemble continued to be out of sync for 2 years and 10 months until September 2016. This period corresponding to the end of hiatus, which I show you first. Perhaps the heat that had been building up in the ocean while the temperature rise were stagnant was suddenly released. As you can see, even multimodal ensemble can sometimes be way off, but over the long term, some errors are smoothed out. For this reason, scientists believe that even if it is difficult to predict in 5 or 10 years prediction, but 20 years to 50 years prediction may be possible in some extent. In order to make this long multi-model ensemble prediction, say, come on, please. First, the temperature and volcanic activity and sun activity and greenhouse gas level. In the past 2,000 years will be reconstructed. And next, create a climate model that can take into account the effect of volcanic activities or activity and greenhouse gas concentration. And next, optimize the climate model parameters so that the temperature of the past 2,000 years can be reproduced as much as possible with this climate model. Finally, with the parameters, long-term multimodal ensemble prediction is performed by, there is so many, I can't count, but very large number of multi-model ensemble. Then, future prediction is different by a carbon emitting scenario. So there is 5 scenarios. Blue is the most severe reduction, and red is the most free CO2 emission. Then, so temperature projection become like here. So blue is within 1.5 degree, and dark blue is to 2.0 degree. And another case is so very more increasing. Then so finally, why should we choose the most severe carbon emission scenario? So Paris agreement's goal is 1.5 or 2.0 degree. This is, please see this panel and look at the upper panel. I see. This figure compares the rate at which species can migrate with the rate of at which in global warming will shift suitable areas for species. So right side the RCP 2.6 or 6.0 is a speed of suitable uh, suitable suit, okay. So considering the northern hemisphere, the more rapid global warming is first 80 species optimal habitat will move northward. Species that cannot move faster than the rate of will not be able to adapt to warming, global warming without human assistance. And only in this case, so low emission scenario allows most of species survive. And the lower panel is ocean life. Also, slow air area allows survive, but faster area, many species can't survive. So that is all of my today's presentation. Thank you. And any comment or question? So I open. It takes 1 hour, but young people don't see 1 hour video. We need to presentation in maybe 5 minutes to show young people. So I type URL of today's transcript in nearby chat. So please try shorter this lecture and please teach me.
Thank you. Thank you so much, Jan, for this.
Thank you.
Valerie, are there any questions that I don't see?
Let me see if there are any in local chat. I'm just telling everyone, don't forget to come on the second Friday of each month to the Gateway to Thinking, where Jan shares these amazing high-level educational simulations. And I did want to congratulate him on his brave use of global interactivity in both English and Japanese, and for sharing the chat with me so I could help with text. Wonderful tour. Applause.
Yes, thank you. Thank you so much for that. We really appreciate it. All the time and devotion to such an important topic. I mean, this is so important. And, you know, I think that not enough is shared with educators about this, and not enough, from my perspective, is done in schools. And I think this is something that educators should be aware of and should pass on, because this is our future, and we need to take care.
Oh, thank you.
Thank you.
Mm.
Thank you so much for that.